This video demonstrates the complete design process of a two-story townhome project using lava. Let's start the program. Open New Lava Project. Lava has very sophisticated input and modeling tools. We will go through these tabs one by one. Input your project number, project name, project location, and any other information you wish to include in your project report. For demonstration purpose, we will input some placeholders and leave the rest blank. Add project description. You can edit this predefined text box to suit your project specifically. If you wish to, this can be included as part of the project report as well, and it will help the plan checker and your coworker to navigate through a larger project. Let's change the building code to IBC 18, and we're using allowable stress design. Keep Type 2 in Risk category. Under Snow and Frost tab, we're using 20 psf ground snow load. We will keep the flood hazard area as none, but you can change them according to your own project. Input the foundation design parameters from the source report. At wind section, let's change the basic wind speed to 95 and assign exposure to type C. Assign appropriate topography condition and any other extra wind parameters. Input the project location here. And since this is a light frame structure, let's change the overstrength factor to 2.5. Input the rest of the seismic parameters. If you would like, you can input further plan description, your client, architects, and the source engineer's contact information. Input your firm's name and logo so they will be displayed on every page of the calculation report. Let's move on to building definition. We are calculating a two-story wood structure with roof truss and regular I-joist as floor framing. Lava has predefined quite a few loading assemblies for different job market. You can change this predefined loading as you need. For example, let's change the item to solar panel and assign the 4 psf dead load. Apply changes. As you see, the dead load is updated. We can do the same operation for the floor loading and the balcony loading with 60 psf live load, and remove any other loading we do not need. The exterior wall has stucco finish. Let's verify the loading. There is no veneer finish, then let's remove this loading condition. Verify the interior wall loading condition and remove all the other loading that do not apply. When there is multiple loading condition, we need to tell Lava which loading is the default loading during modeling later. In this example, there are two floor loading. One is residential unit floor loading with 40 psf live load. The other is 60 psf live load, where it happens only at balcony. Let's tell Lava, whenever modeling floor load, Let's use unit residential floor load as default loading. At the Elevation tab, let's verify the wind height, plate height, and the floor framing depth. And at the condition where there is parapet, we can check this box to consider the extra wind load. At the Wall tab, we need to input the wall length at both levels so that the seismic weight can include these wall weight. Let's quickly input some numbers for the exterior wall length and interior wall length in X direction, and do the same for the Y direction. We need to input a wall length for both levels. There is options to input some custom wall weight. For example, if at the ground level we have some stone veneer, we can add extra heavier wall finish, so these can be included in the seismic weight. After adjustment, the total weight is updated accordingly. And since we do not have this condition, let's remove it. At the Schedule tab, you can see all these material and grade we are going to use for this project. And of course, you can change them accordingly as well. For Materials and Joists tab, you can edit these text box to match construction drawing. For Design Procedure, you can either use flexible diaphragm, rigid diaphragm, or semi-rigid diaphragm. You can toggle the ratio of flexible and rigid diaphragm. For this project, let's keep it as flexible diaphragm for wood structure. We are going to apply seismic load, input the correct R value, and since we are going to have interior shear wall, let's uncheck the box for redundancy factor. Do the same operation in the X direction. In a vertical distribution, let's make sure the snow load is included. In the Story Drift tab, verify the correct values for allowable story drift and check the box to enable deflection limit for story drift. We are to apply wind loads and snow load. This concludes the input part of lava. Let's move on to the modeling. Lava uses simplistic and powerful graphic interface to help the user to build the entire structure. Lava uses DXF files as background for modeling. These DXF files can be easily produced from the architectural CAD background usually provided by the architects. We just have to make sure all the useful information, such as walls and roof lines, are included in the correct layers. We can import these DXF background into Lava. Make sure we pick the correct layers for each level. Let's start with the roof level. We use Plate tool to apply vertical load. This thin orange line represents the direction and the span of framing member. We can double-click and make modification as needed. By default, lava spans the framing members in the short direction. Let's change that into long direction. Here is the summary of all the loading on this roof plate, including snow load. If needed, extra loading can be added. For example, you can add extra dead load at the back of the roof. Simple like that. And you can also delete them if needed. Let's continue putting plates on the building. We can use the resize tool to make modifications as needed. Let's save the project. Use beam tool to place extra beams on your building. They will be supporting the plates you just modeled. Double-click this beam to make modifications, including assigning cantilever at the left support and the right support. You can also change the embraced length. Basic Loads tab displays all the loads we're adding on this beam after modeling. Under Modify Loads tab, we can add extra loading as we wish. For example, we can add exterior wall weight. Under Sizing tab, we have many options to design this beam, including all the common types of structural engineering, composite lumber, and even steel beam. Let's assign a 5 1/8 inch wide glulam beam for this one. And let's assign a double 6-inch stud support. We anticipate a lot of glulam beam usage in this project. Let's go to Setting, Preferences, Building Layout, and Beam tab to change our default beam preference. Let's change the support to a double 6-inch studs as well. Now, every beam we place from now on will be automatically a glulam beam. And of course, we can always change the beam type in the setting. Let's go ahead and design a 4x header. Press Shift on your keyboard to activate the snap function. This will help you place the beam exactly where you want them to be. Double-click. Under Sizing tab, change the beam type to 4x lumber. And since this is an exterior header, let's go ahead and add 2 feet of exterior wall weight. Let's add some bearing wall at the back and the front of the building. This way, when we design the beams at the lower level, the wall weight of upper level will be included. Let's move on to diaphragm. Please select the lateral direction for new diaphragm. Let's start with X direction. Since there will be no interior shear wall in the X direction, one large diaphragm will be sufficient. And in the Y direction, we will be having interior shear walls at the unit party wall, so we will make sure to have 3 smaller diaphragms. Now let's start adding shear walls. We can use the hide elements function to hide certain elements to have better visual. These are simply hidden, not deleted. Let's add a 3 feet shear wall panel here. Double-click, modify the shear wall length. The shear wall tool is very similar to beam tool. Use copy and paste function to speed up the modeling process. And use the resize tool to make modifications. Sometimes we have window within the shear wall panel. We can use the window tab to add opening, so we can design the shear transferred around this opening. And since we do not actually have window for this shear wall, we can just cancel it. Let's continue the shear wall model and make sure to use the copy and paste function. I have been ignoring the unit on the right side. It is an exact mirror of the unit on the left side. So let's copy everything from the unit on the left side and then make a mirror. Let's double check and remove duplicated structural elements. And then place all these new elements in place. We can remove this duplicated shear wall as well. Now let's check if all of the diaphragms and plates and beams are successfully mirrored. Let's move on to shear line tool. Shear line collects the shear force from the diaphragms and then distributes it within the shear panels. You have the option to distribute shear by stiffness. Shear line also calculates the drag force. Use copy and paste tool to add another shear line at the front of the building. Let's finish adding the shear lines in the y direction. This concludes all the modeling on the roof level. Let's move on to the floor level. Before adding plates, we can use the overlay function to find out where we can accurately place beams around the stairs. Seems like we need to add a landing beam here. And another one here. Let's move it to the correct location. Let's remove the overlay and use the move and resize tool to accurately place these beams. Now we can keep adding plates and beams to finish the gravity modeling. Let's bring back the roof overlay. There is a line of a non-bearing wall from above. Let's place up a garage girder here. Let's continue with adding the plates and beams. Similar to the units on the left, we can bring back the roof overlay and accurately place beams around the stairs. When we model the beams, as long as graphically it is correct, all these reactions will be transferred accordingly. At this location, this is actually a lower roof. Let's double click and change the location to roof. And then the basic loads shows that the correct roof loading is added. At the front of the unit, let's bring back the roof overlay. And we notice that there is a line of bearing wall here. So let's add a beam here to catch all the loading from the level above. And this plate is another lower roof. We can also change it to any other loading we like. For example, we can change it into a balcony loading with 60 psf live load. This is up to your own project. Now let's move on to diaphragms. Since we have an interior shear wall at the garage wall, so we can no longer use one large diaphragm in X direction. Let's move on to shear wall. This is a very short wall pier. It is unlikely to satisfy the requirement of height to width ratio. So under sizing tab, let's change the wall type to Simpson strong wall. Use a 2 feet panel. Use copy and paste function so we do not have to repeatedly tell Lava to use Simpson strong wall. Let's add 4 feet wall panels at the garage wall. In the y direction, The shear walls from the upper level will be perfectly aligned with the shear wall on the lower level. We can simply use Ctrl+C on your keyboard to copy these elements. Go to lower level and use Ctrl+V to paste them in place. But pay attention, the hold down on the floor level and the hold down on the roof level will be different. Let's change them accordingly. And similar to the roof level, we are going to use the copy and mirror function to add the structural elements to the right unit. Now let's add some shear lines to the building. All the shear walls must be part of a shear line to be properly loaded. This has concluded all the modeling of this structure. If you do not wish to make further modification, we can start calculation right away. Just click the Analyze button. Lava works very quickly. It will calculate every single structural member we modeled. They are listed on the left. If any of the structural member failed, it will show up in red. In our case, every structural member has passed the calculation. Let's go to Report and click Print Review. Lava gives very comprehensive report. Here we have all of our input, the model overview, and the results of all the beams and shear walls. You can choose what section you wish to include in your report. For example, let's remove the project description and review again. As you can see, the project description is removed accordingly. This is simply a quick overview of a complete design process. We will discuss each calculation module, modeling technique, and customization tool in detail in future videos. Thank you.